Hello, everyone, and welcome. This is our hands-on learning session, and if this is your first time with us, we will welcome you to the space where we can learn, create, explore together. And if you've been with us before, welcome back. Thank you for coming back and connecting with us in these spaces. I'm Aileen Rizzo with the AIM Center, and I'm here with two of my colleagues, Dr. Steve Pauls and Elin Anderson. And they'll be kind of leading our session today. And so we're excited to have them. At the AIM Center, we're committed to working toward a more equitable world through math and science education. You can learn more about our work by visiting our website at aimcenter.org. And we'll have some resources later to share with you and some upcoming events. Along the way today, you can use the chat and the Q&A features to ask questions, share your progress, say hello, tell us where you're from. We're coming to you from the Central Valley, at the heart of the Central Valley here in Fresno, California. So we love to know who's joining us today, where you're from, and excited to have all our attendees here today. So today we're going to engage in a session called Boats That Float. We're going to really concentrate here on engineering a little bit more. We've kind of had a little math emphasis, some art. So we always like to explore the different realms of STEM and how they interact together. So Steve and Elin, I'm going to turn it over to you to share a bit about the STEAM content for today and how we'll be engaging together. Thank you for hosting us today and exploring this topic.
Good afternoon, everyone. As Aileen said, my name is Steve, and we want to talk a little bit about boats that float today. We are surrounded by a constant stream of examples of relating to science, math, STEAM integration in our lives. Hundreds of times a day, a student experiences small interactions around science and math concepts that we talk about in class. What we do in class doesn't have to be difficult or complex, but it just has to be relatable to what the student experiences in their own environment every day. So our goal today, and our goal in our hands-on series, is to all be learners together, to experience simple STEAM concepts as a group and understand how the interaction of these concepts work into already what you do in the classroom, which can be a powerful learning experience for both student and teachers alike.
Yes, thank you, Steve. And well, again, welcome everybody today. My name is Elin Anderson. I'm one of the coordinators here at the AIM Center for Math and Science. As Aileen mentioned early at the beginning, today we are going to be engaging in an activity that highlights the E in STEAM, which is stands for engineering. Again, we try to highlight activities through our hands-on sessions that highlight all the elements of STEAM, but today we're really going to focus on the element, the E part, the engineering. So, and during this activity, we are going to engage in several of the next generation science and engineering practices. We're going to be working on asking questions and defining problems, and that defining problems is really key to engineering. We're going to be planning and carrying out investigations. We're going to be testing a lot of different things, testing to see what will float in our boats, how many things we can float in our boat. And we're going to be constructing explanations and designing solutions. We're going to be designing our boats, and again, that designing piece is really key to engaging in engineering and understanding engineering. So for our activity today, you will need a tub of water, some squares of tinfoil, some pennies or other small objects that you could put in your boat, possibly a ruler if you wanted to think about being precise, and some scissors if you need to cut out your squares. And so while you're getting your materials, getting everything rounded up, Steve, can you tell us some more about boats?
Absolutely. Boats are one of my favorite topics. I have several kayaks myself. Humans have a long history of boat making. For thousands of years, humans have been designing, they've been building, traveling by boats all over the world in different shapes, sizes, and materials. From ancient Egypt, where boats were made out of reeds, to sailing ships, wooden sailing ships that can traveled around the globe. Or maybe it was a tri-hull speedboat that can travel 100 miles an hour, or even a giant cruise ship that could carry up to 5,000 passengers at one time, or at least before this year could carry up to 5,000 passengers at one time. Boats come in a wide variety of different shapes, sizes, based on the building materials available and the basic needs of how a boat might be used. For example, here are two boats on the left and the right that are similar in shape, but very different in what they're made of and how they're used. The boat on the left is a boat made of reeds, and it is made out of local material and can carry quite a bit of weight and travel long distances. The boat on the left looks like a very sleek model compared to the boat on the right. The boat on the right looks a little sleeker than the boat on the left. Would you believe that boat is made out of concrete? Concrete Canoe is an engineering competition that colleges and universities have every year. Fresno State engineering department has been part of that. I don't know if they're doing it this year, but they have been part of that competition. If you go to their engineering building, you'll see that, I don't remember which side it's on, but there is a concrete canoe out front, which was one of their entries. But it teaches students that even materials you wouldn't think that would float can, given the right design and composition. So today, what we're going to do is we're going to build boats out of simple materials. We're going to build boats that out of aluminum foil that you can have your students build in the classroom.
Okay, great. So I'm going to go ahead and switch my camera. So hopefully you can hear me, but see I have a tub of water ready. Hopefully you got all your materials together, and we're going to do some exploring together. So I talked a little bit about the next generation science standards that we work, our K through 12 students work with, but really students are really intrigued, even young kids are intrigued by things that float and things that don't float. So for instance, I don't know if you've ever tried this, but I have these little tangerines or little clementines. And if I put one in my water that's not peeled, it floats. But if I put one in that I've peeled, it sinks to the bottom. And that's just, to me, that's amazing. And it's because that the peel is actually quite porous and filled with air. And so it acts like almost like a little life preserver for the tangerine. And the tangerine itself, the actual fruit, is denser than the peel, so it sinks, which I find just fascinating. And I just wonder like what other fruit, floats or sinks without the peel. And so some items that I have that we're going to be testing, I have some pennies, and obviously, or if I put it in, a penny sinks. And then I have these little dominoes that I think are made out of, I think plastic. Oh, that sinks. I have a marble. Oop, if I put that in, that sinks pretty quickly. And interesting shapes too. This is round. The domino is a rectangular shape and the penny is a circular shape. I wonder if that'll make any difference. So it's interesting because we have, we're going to be making a boat out of tinfoil, which is metal. And I wonder, you know, is it going to hold the penny, which is also made out of metal? This sink, but we're going to make a boat out of tinfoil. So hopefully you have some tinfoil ready. I have some squares here. And I'm just going to make a little, I don't know, like almost like a canoe. I'm going to fold these in. You can make yours any way you want right now, but I just folded it on the diagonal and then folded the two sides in like this, sort of get them sealed, and then fold these two sides back and open it. And I'm going to make, oops. The nice thing about tinfoil is it's pliable, so I can sort of make the bottom a little flat. And if you have any questions, feel free to put them in the Q&A. Or in the chat. We'll be watching that. So, I have my boat made. I wonder how many pennies it will hold. If you want to try and if you want to guess and put how many pennies you think it'll hold, go ahead and feel free to put that in the chat. Any guesses? Okay, I see 2.
2 pennies, 10 pennies, 3, 4.
4. Okay, so let's see. Any more guesses? Okay, here we go. So 1, 2, and again, if you are making your boat, you can put your items in your boat too and see. 3, 4, 5, 6, 7, 8, 9, 10.
Oh, numbers are going up.
Yeah.
12, 22.
Oh, no, I have 22, 10. So we passed our 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, 20. I could see the water coming over the edge as I did that. So 20 pennies. Wow. That's quite a few. I'm going to take another piece of tinfoil and let's see how many. Again, if you have your tinfoil handy and you want to experiment with your objects again or try a different objects, feel free to explore along with me. I'm going to go ahead and make another little boat. Pretty much the same structure. My makeshift canoe vessel, make it sort of flat on the bottom. And now let's see how many of my dominoes will fit. How many do you think we'll be able to fit more or less dominoes in the boat than the pennies. Less? 2? So I'm seeing 2 less than the pennies. So again, we had about 20 pennies that fit in the boat. So let's see. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm trying to be careful about where I place them to just disperse the weight evenly. 12, 13, 14, 15, 15. So actually less than the pennies.
That was a lot more than I thought.
Yeah, more than you
compared to
thought.
the pennies. And there's nothing magic about the design of the boat that Elin has made. There are many different ways of making your boat and your design and designing your boat. And that's part of the scientific process. Try different designs, try different iterations. Make a guess at how many pennies each would hold. What are the variables involved? This is something as easy for a young child to do, and is just as exciting for a older child who is trying to maximize the number of pennies.
Yeah, I'm going to try a little bit different with this with the next one because I have marbles. So I'm going to make it just a little, just because I'm curious. Just flatter on the bottom, so more space. Just folded up the top part, made a little edge on each side. And so now I'm going to see how many marbles I can fit in. And again, feel free to explore with me. So if you're making another boat, let's play together. So now I have marbles. And you might have children that want to start, one side, 2, 3, 4, 5. Do you think we'll get as many marbles as we did pennies? So right now I have 1, 2, 3, 4, 5, maybe 10, 6, 7, 8, 9, 10, 11, 12. 12, probably 11. So in my last, just because, again, your older kids might think about, finding different objects and exploring, but younger kids, they might need a little bit. It's all about the imaginative play and, thinking about different characters and what they might be doing. So say our favorite characters wanted to go on a little adventure. I have some of my Lego friends with me. And again, these stick with my first design. these little guys are not, when I test them, they actually do float. But I wonder how many I could fit in my boat. So I have one friend, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 Lego friends in a boat right now. Oh, one more. 11. And they are, again, they float. I could tell they're much lighter than the other objects that I put in. So I could tell that the boat was not going down as much as it was with the other objects. The water wasn't being displaced. So we want to give you some time to keep on exploring. So Steve, do you want to give them another challenge?
Sure. So there are many ways you can approach this and have your students experience this. What we would like you to do now is considering your new profession as a designer, an innovator, a boat building master. We would like you to design and build and test another boat that will hold more pennies than the first one that you did. Pennies or marbles or dominoes, whatever you're putting in your boat. And think about what changes did you make to that boat design? What did you learn from the first design experience or the first iteration? How did that affect your next design? And how can you make your boat better at holding more pennies? What do you need to do differently? And so those are the type of experiences that we have as we do those iterations. And think about the questions that as you are building your boat, you're experiencing this design challenge. Think about what questions you might ask your students as they're doing it.
Great. So yeah, we're going to give you some time on your own, just a few minutes. It's always good to have some, just like our students, we need that independent time to think and process and play. So we want you to encourage to continue making. Feel free to share your thoughts in the chat. If you want to share how you're modifying your boat, that would be great. We'd love to hear about your thoughts. And yes, you can add more foil to your design. And you can add more foil. The design can be different, or more foil with the same design. It's whatever you would like to explore. Be sure to come back. Also, we want you to think about, if you are going to have children engage in this activity, what are some things you would do? What are some questions you would ask? And be sure to come back after the play break, because we have an interesting story to share about a unique boat and some more unique boat designs. So have fun designing, and we'll see you in a few minutes. So welcome back. I hope you got into designing, exploring some more designs, and I see a lot of interaction in the chat, which is great. Yeah, some questions about how to share your pictures. You can share them on Facebook or Twitter at using @AimsEd. And so now Steve is going to share with us about actually a really unique boat that one that I had never seen before.
Yes, this is quite a unique boat and different than I had ever seen before. As I said, boats come in many different shapes and sizes. Picture on the left here is a image of a Chinese boat, an old ancient saipan that was used as utilitarian boat, used for many different purposes. The image on the right is a modern day boat that is used for a very unique purpose. That boat on the right is called a floating instrument platform, or a flip ship for short. And it is quite unique, oceanographic vessel that is used for research. It was built in 1962, and it now operates out of the Scripps Institute of Oceanography in San Diego, California. It's a one-of-a-kind ship. Flip is 355 feet long, about a little longer than a football field. It's spoon-shaped. It has one end is very wide and bulbous, and then a very long hull or handle. And it's essentially a buoy, or you can think of it like a fishing bobber, which can flip from horizontal to 90 degrees vertical by pumping 700,000 tons of water into one end, into the handle of the spoon. It does that over about a 30-minute period, at which it is about 300 feet of that ship is then underwater. Remember, it's only 355 feet long, so 300 of it is underwater. That doesn't leave very much on top. Now, sinking a ship doesn't seem like a very good idea. That's kind of opposed to what we're trying to do with our aluminum boats and what most ships or boats are built for. But for this particular boat, they sink it partially on purpose, because along the handle of that spoon, the shaft of the boat, the hull of the boat, they have a raft of sensors, which are suspended below the ocean surface. And the flip ship can then easily study ocean temperature, ocean currents, geophysical qualities of the ocean floor and its structure. It can listen for marine mammals, especially like whales, as they call to each other, different pods call to each other across the ocean. And it can do this all from a stable platform in the middle of the ocean. Once they're done doing their research at that particular location, they can pump the water out of one end of the ship and air into the other end of the ship, and it will transition back from horizontal to vertical. It's really quite fascinating. The pictures don't do justice for it. If you're interested, you can go to YouTube or Bing and type in flip ship, and they'll show you a video as that ship transitions from horizontal to vertical and vertical to horizontal. It's really quite amazing.
Wow. Yeah, that is one unique ship, and it's just amazing all the that's a lot of engineering that went on into designing that, but it definitely has like a unique purpose, and that's all about what engineering is all about is designing things for unique purposes. So I'm to help create or come up with solutions to problems that you may have, or like a community may have. So I'm going to go ahead and share my share my webcam again, because yeah, as I was exploring with the boat design, thinking about how, you know, with the flat surface, you're able to get a lot of items in. And then thinking about my little Lego people, I was thinking about other items that might float and things that you have in your house. So I have like a plastic lid here. And so I was starting to play around with that. And so I put it in the water to see if it would hold, not necessarily the pennies, but just, you know, create a more enjoyable ride for my Lego friends, and they can stand on here. But I thought, you know, that's probably not very comfortable for them. And so if I was, you know, thinking about how to make this better, I was inspired by and thinking about where, you know, this would, because it's round, would move in a circular motion. So then I created this circular flotation, or circular lazy float for them. I added the egg carton. I cut it up and glued it to the lid to make it a more stable ride for the little friends, and they could probably fit more than two in each. And then put a sail on a straw going out, because I figured that way when the wind catches it, it would go around and they would have a nice lazy circular float down the river or wherever they wanted to go. And again, so just raiding my recycle and pantry, found some items to think about, you know, designing for a purpose. And obviously the lid floats, so that's fun. But then I was thinking, well, what if my Lego friends wanted to go not on a circular ride, but in a straight motion from one point to the other. So I designed again, finding things that were readily available. This is like a half of a carton, or a carton cut in half. I developed a two-seater, where you could probably fit more than two in here. Again, using the A carton in the middle to give the people a more stable ride. You can have people looking out on the side. And then a sail in the front, so when you blow, it goes across. So again, designing for a different purpose. And again, all about creating that joy in making and creating things that have a purpose. So this might be lead to a talk about, well, how would we design a boat for people? How big would this need to be for actual people to fit in? Yeah, and with a long container, this is not very long. You could have races to see, you know, whose boat could get to the end the fastest. As you were building your boats, did anybody think of questions they might ask children as they engage in this activity? Or were you able to to make a boat that held more objects than your first boat?
One question I had is, did it matter how the pennies or whatever objects you were putting in, does it matter how you put them in the boat?
Yeah, that's something I was thinking about as I was putting objects in too. You know, and with the pennies, you can stack them in, but you can stack them on top of each other, but you can also put them in the, you know, lay them on the surface and then layer on top of that. So really, there's a lot of different goals a child could have in mind in designing their boat. They could design it for to hold the most objects. They could design it built on, you know, the direction they want it to go when they put it in the water. Yeah, a lot of different types of designs. So as children engage in this activity, you want to really, you know, think about how they work with the material, the joy and excitement that they have as they build their boat. You know, and young children may just really have fun just thinking or discovering which objects float and which objects sink. Oh, I have it. Like, how about, or a combination of the 4 items? So we just put in all pennies or all marbles, but, you know, a different question could be, could your boat hold different items of the same, you know, different, like a penny, a marble, and a domino, different material in the same boat? That's a great question.
One thing I have done with older students is I have an example here where I've taken a wooden block and I've taken that same piece of tin foil, square piece of tin foil, and have wrapped it around the block just like you would wrap a present, right? And so then when I drop the foil out, then I've got a boat that has very well-defined sides and base. And for older students, what you could do is use a series of different blocks. Here's one that was a rectangle. Here's one that is a cube, right? And then you have a base that has different areas. And an older student could calculate that area, and you could compare that to the amount of pennies it holds. In the past, I've had, if you have a class of 30 students and they each make 3 boats with a different base, you could lay out a number line, and they could put your boats on where those, in relationship to the number of pennies that it holds. And very quickly you get an idea of which boats are better at holding pennies, maximum number of pennies. If you have that many boats laid out, you get a nice distribution of how many pennies it can hold. It's a fun experiment.
We have a question. Does the foil hold the same as the plastic lid? That is a great question, and we have time. I can go ahead and let's find out.
Yeah, I would love to know. Let's hypothesize.
Okay.
How many, go ahead and put in the chat, how many pennies do you think the plastic lid will hold? Will it hold more pennies than the aluminum boats? Less pennies? A little bit, a lot less, a lot more? What do you think?
More. And remember, we had 20, right? 20 that 20 pennies. So I'm thinking, or what, we have a lot of estimates or guesses, hypotheses in the chat. Oh, 35. More pennies than 20. So let's see. Oh, 40 plus.
Oh, they're challenging you now, Eland.
I know. I got to be careful about this. Okay, so 1, 2, 3. I'm going to be strategic about how I
I think you're playing Pente.
5, 6, 7, 8, 9, oops, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we're past the 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, past the 30, 31.
Holding strong.
32, 33, 34, 35, 36, 37, 38, 39, 40. Oh, we're past the 40. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 50, was that 50, 51? So yeah, 51. So it held more than the boat, than the foil boat. It has like a little ridge in here, but not interesting. You think it would hold a lot more, but it held 30 more pennies, more than double. Yeah, so interesting. And again, I wonder if you put, I was putting them one at a time, so this would be another interesting question. I put them in all one at a time, but I wonder if you put them in like a handful, like if you took a handful of tin and dropped them all at the same time, would that make a difference? Because we're sort of gradually adding the weight, but does it make a difference if it's like, but yeah, just all sorts of fascinating questions that you could ask and explore, investigate.
Or somebody asked before is what happens if all the pennies are stacked?
Mm-hmm.
Or what if you put the pennies on when the boat's not on the water and then you slowly lower the boat into the water? Does that make a difference?
Yeah, it's a great question. Great question. And using a larger container can make a difference too, like seeing if that, yeah, I love the idea, Steve, of you said of thinking about the surface area of the bottom and then exploring that and getting some information from that and exploring the information that you gather from that. That's a great thing to do with older students, and take that information and make a graph, or just explore that information, think about how they can represent it. some really, really interesting things to explore. And again, like, you know, how would they think about designing, taking their prototype, and like, how would they design it for humans to use? What would they do? How would maybe this boat was made for holding, like my little lazy circular float is made for relaxation with some you know, people, but what about a ship that you need to transport animals? What would that look like? How would it be different? So all kinds of things to explore. So again, we really looked at some of the practices related to the next generation science standards, and really this activity had a lot of engineering involved in it. And so really thought about defining a problem, like what do we want to design our boat to do? Hold the most pennies, make it to transport people or provide them some type of a fun ride. Planning and carrying out investigations, you know, testing it with the water right there, actually seeing how many pennies it will hold, or how many Lego people, and then going back and modifying and adjusting our design to make it hold even more pennies, or design a boat for different purposes, different functions. And thinking about younger children too, again, I use the Lego friends to think about that imaginative play that we know is so important for young children. Another way to get children interested in exploring an activity like this might be to start with a children's book. There are two great ones on this slide. Who Sank the Boat by Pamela Allen, and which is about, you know, seeing how many animals can fit in the boat, and which animal is the one that actually sinks the boat. You'll have to read to find out. And then What Floats in a Moat. So some animals are designing a boat to float across a moat, and what materials do they use to design their boat, and what kind of boat do they design? So that might be a starting point to get young children interested in exploring an activity like this. Again, you know, be done during bath time. Again, just starting with thinking about how things, what things sink and what things float. So we're so excited that you were able to join us this afternoon. Really appreciate your participation, and anxious to see the other boat designs you come up with. So I'm going to hand it over to Aileen now to.
Hello, everyone. We don't want you to leave yet because we have some exciting announcements to make, and we have some giveaways. So please stay with us. So the first thing I want to announce is our paper Imagineering session that's coming up. The cost is $65. It includes play shop materials that you're going to get in the mail and some other free materials all around. How can we use paper? Very common item, but a very deep material that we can do a lot of exploration with. And so we're excited about this. The registration for this ends Friday. So we want to make sure that you register in time because we need to get you your materials to have for that session. So we are going to raffle off some registrations, and we're excited to do this. This will include everything that you can come with that $60 value for free, get to learn and play with us. And so it will be an exciting time to do that. Are we ready to do that? Here we go. So we have all the names here on this wheel. You do have to be present to win. So we'll have you say, I'm here in the chat, saying you are here, and we'll make sure to get your name and get everything that we need from you. So let's see who our first winner is here. All right, Lisa Huertal. I don't know how to say that name. I'm sorry if I said it wrong. Lisa, are you here with us in the chat? Hopefully she's here and can respond. Hello, Lisa. Any response? All right, let's try again. Let's see another name here. We'll see what our wheel gives us here. All right, Angelica Rey, are you here with us? Can you respond in the chat that you are here? Yes, Angelica says, yes, I am. Great, Angelica. You are a winner of a free registration for Paper Imagineering. Okay, congratulations. Let's see, another winner here. Okay, let's see where it stops.
It was an extra hard spin.
Yeah. Sandra Falcon. Sandra Falcon, are you here with us today, still listening and ready to say, here I am for this raffle? All right, we'll just give you just a minute more. All right, I guess we'll do one more spin then. All right, Blanca Barajas. Are you with us still? And can you respond in the chat? Yes, she is. Congratulations, Blanca. You won a registration to Paper Imagineering. Thank you for being with us today and for doing that. And I just have one more announcement. Our next webinar will be fold up polyhedra. And so we're going to be exploring two-dimensional shapes and how they change into three-dimensional shapes. And making this model that you're seeing here a way for children to engage and explore. Registration is open on our website. Remember, these webinars are free. And so if you'll go there to our website and make sure that you secure your spot and get a reminder of when that happens next month. Thank you again for participating. Thank you again to Elin and Dr. Pauls for this great session around things that float, how to create boats, how to be engineers, and reclaiming these spaces where we're all included in doing STEAM together. Please visit our website for the resources around this activity and all our previous webinars as well, hands online. We'll be sending you a coupon code for those who won today, so be watching for that. And I look forward to seeing you at our Paper Imagineering, and if not then at our next webinar, Hands Online, next month. Thank you again for all of us who attended today, and we hope you have a great rest of the week. Thank you.